Number 3. All right, so I just want to do this again. So you have 3 scenarios. The buoyant force is equal to the weights. The buoyant force is greater than the weights. The buoyant force is less than the weights. This means that it's either floating like a ship, or it's in the middle of the water column and it's not going to go anywhere. It's not going to go up or down. There's no net force. Understood?
Yes.
B, the buoyant force is greater. Like if you have a football and it's going to rise. Correct?
Okay.
And C, doesn't look so good. Where the weight is much greater. It's like lead. So it's going to fall. Correct?
Yeah.
Yes? Okay. So, next. What else have we have to do? Okay. Let's look at Pascal's principle. Pascal's principle is simply stated as an equation as F1 over A1 equals F2 over A2. Clear?
Yeah.
So I'll give you an example. Let's say I have a car that weighs 100,000 newtons. It's a pretty big car. Big car.
Yeah.
Okay. And let's say it has an area of, it's sitting on an area of 1,000 square centimeters. 1,000 square centimeters. Okay? Yes?
Yes.
Okay. So now I have a piston of 10 square centimeters. What force do I have to apply to that piston in order to be able to lift that car? So it's 100,000 newtons over 1,000 square centimeters equals question mark over 10 square centimeters. Clear?
Yeah.
Yes?
Yeah.
You okay with that?
Mhm.
Yep. And the answer is 1,000 newtons. So it's going to be 100,000 times 10, which is 1,000,000, divided by 1,000, which is 1,000. Okay, 1,000 newtons. Now, this is something that's very, very, very important. What's the trade-off? So this is a piston. So I'm going to apply 1,000 newtons to this smaller piston, and I'm going to lift the car, correct? What's the trade-off? What's the trade-off? The trade-off is you have an increased distance. See that? This is a very large distance. This is a very small distance. So D1 is much greater. Question on the test. What's the trade-off? I only have to, it's like a machine. It's like a simple machine. I apply a small force over a large distance to raise a much larger force, a smaller distance. You get that?
Okay, yeah.
That's very important. So that's Pascal's principle. Okay, so I think I did everything on this board.
This one.
Oh, here's one. Talk about Archimedes' principle. Remember what Archimedes' principle is? It is the weight of the fluid displaced. So, if a dirigible, you know what a dirigible is? Big hot air balloon. Dirigible. It's all I's. D-I-R-I-G-I-B-L-E. It's all I's. Right? So, if that's floating in the air, and it's 3 tons, right? It's floating in the air, and it's 3 tons. It's a 3-ton dirigible. What's the buoyant force? 3 tons. If it's a 3-ton dirigible, it's going to displace 3 tons. If it's floating in the air, correct? Yes, if it's floating in the air, and I know it weighs 3 tons, it's going to displace 3 tons of air. That's huge. Correct? I think I covered everything. Okay? Stop.